Question number 9. A progressive wave is described by the equation y is equal to 5 sine 2 pi times tan t minus x over 5. Okay, so x, y centimeter and the t in second. Calculate the speed of the wave. To calculate the speed, we can refer to the equation. The speed of the wave is frequency times lambda. And how you can find the value of the frequency and lambda from this equation? Here you can use the, okay, here we have because this is 5 sine, so this is 2 pi, so meaning here this is 2 pi times 10 is a 20 pi t minus this is 2 pi x, this is 2 pi x divided by 5. So now for equation here, so now this is, this is omega, right? Because general equation here for the wave is a sine omega t plus minus kx. And now here we can use, because this is omega times t here, omega here is equal to 20 pi, and omega is also is equal to 2 pi f. And now you can find the value of the frequency here, right? Frequency here, so the frequency is pi is equal to 10 hertz, right? 10 hertz. So the next is what is the value of the lambda? So to calculate lambda, you can use the k, because k here is equal to 2 pi over lambda, and here is equal to 2 pi over 5. So now you can find the value of the lambda here and lambda here. You can use the equation here. So the lambda is equal to 5 cm. Okay class, now you can use the equation v here, because the frequency is equal to 10 and lambda is equal to 5, so convert to the meter is times 10 power of minus 2. So now here the v here is equal to 0.5 meter per second. So next question is, what is the vibrational velocity when the time t is equal to 0 and the particle x is equal to 5 meter? So if you look at the equation here, so this is equation for the displacement y here. So to calculate the velocity, as you know, for the velocity you can use the derivative or differentiate dy dt. So for the differentiate of displacement y here, this is equal to this is 10, this is sine, this is 2 pi, so here we have a 2 pi times 5 times 10 is a 100 pi. Derivative for sine is a cos, and we have a 20 pi t minus 20 pi x divided by 5. So this is how you can derivative for the displacement y, from the displacement to the produce the velocity v. And now for the t is equal to 0, and the x is equal to 5 cm. So what is the value of the v here? So you can use the equation here. So okay, right here, so the v here is equal to 100 pi cos this 0, and this is minus 2 pi, right? And this is 5, this is 0, this is cos minus 2 pi, and can use the cos 2 pi here. cos 2 pi here is equal to, you can use 2 pi, and time pi times 100 is equal to 314, because unit here is a centimeter, so this is centimeter per second. Or you can use you convert to the meter, is 3.14 meter per second. Right? So this is how you can calculate the velocity. Okay, when the t is equal to 0 and the x is equal to 5 cm. Continue to the number B here. Wire mass 30 kg is stretched between 2.100 cm apart with a tension for 70 Newton. When the wire is plugged, standing wave are formed. So meaning here, let's say we have a 2 point here, and we have the wire fixed at the end of both end of the wire and plug. So now we have moving the standing wave here. This is for the fundamental here. So now here calculate the fundamental frequency. For fundamental frequency for the string here fits both ends. Fundamental frequency is given by the equation 1 over 2L square root T over nu. And the information for the length here is a 100, because this is centimeter, use convert to the meter is 1, and the nu is mass per unit length. Here is a 30 kilogram. That's 30 kilogram. 30 convert to the kilogram is a gram minus 3, and nu is a mass per unit length. So the length here is a 100, right? Length here is a divided by 100 centimeter in times 10 power of minus 2, convert to the meter, and then tension force to make the tension of the string is 70 Newton. So now you can find the F naught here. So right here from the calculation here, F naught is equal to 24.15 Hertz. Right? And calculate frequency, third overtone frequency for the wire. The wire stretch between 2 points. Third overtone is referred to the fourth harmonic, right? So the fourth harmonic is referred to the fourth harmonic is referred to the 4 times fundamental frequency. So frequency for the fourth harmonic is equal to 4 times fundamental is calculate from the 24.15. So frequency for fourth harmonic is equal to 96.6 Hertz. Right? This is a frequency third overtone. And next is if the tension force is double. So meaning here the tension is double, because the fundamental frequency is proportional to the tension of the string. The fundamental frequency is proportional to the T, and this is square root T. Square root T. So now here, if you use a ratio between the new frequency, right? And here is a new frequency, and initial frequency is equal to, so here we have because new frequency is two initial tension, and this is initial 2, right? So here to calculate the F new here, F new, so this is equal to, so sorry, this is also square root 2. So f nu is equal to square root 2 f naught. So here we have a f naught. We already calculate from question number 1 is 24.15. So you can find the value right here. The fundamental frequency of f nu if the tensor double is equal to 34.15 hertz. Right, this is number 2. Okay, continue to the number C. A stationary loudspeaker radiates sound with a frequency 1000 Hz. Uniform is all direction. At distance 4 meter, intensity of sound is 0.95 watt per meter square. Calculate power of loudspeaker. They say this is a speaker, and the speaker produces the sound wave, right? Sound waves around the speaker. So this is let's say this is a radius at the distance 4. Let's say this is distance 4, 4, let's say 4 meter here, right? 4 meter, but the distance 4 meter from the speaker. Intensity of sound is 0.95. So now what is the power of loudspeaker? So as you know, to the intensity, if you relate the power here, so intensity is given by the equation. Intensity is equal to power divided by area A. So the calculate the power of loudspeaker is intensity times area A. Intensity is given by the 0.95. So what is the value of the area A? So this is area A is referred to the circle here. So the area here is a 4 pi r square. So at the radius or at the distance 4. So meaning the r here is equal to 4 meter, right? 4 meter. So now you can find the value of the P here. So if you use the calculator, P is equal to 191.01 watt, right? And number 2, frequency of the sound heard by the child if he approaches the sound. So meaning here we have the observer approach to the source of sound come from the speaker. So meaning here we have the equation, or look at the Doppler effect. The frequency observed by the observer is equal to speed of sound. This is constant. Speed of sound is a 330, right? 330 meter per second. It depends of constant given by the question. Let's say here the question gives you the constant V, or the sound speed of sound 330, and plus minus speed of the observer divided by speed of the sound plus minus speed of the source, and time frequency of source. Because the situation given by the question is the child approach. So meaning here the source is static, so Vs is equal to 0, right? So what happened to the plus minus here? Because when the child approach to the source of sound here, or source approach to the speaker, so meaning here we know f frequency observed by observer is greater than fs. Yes, f not greater than fs, or meaning here this is increased value of here, right, compared to the f source. So meaning we must use the positive here. So now we have a f naught is equal to v plus v naught, because vs is equal to divided by v times source frequency, and the speed of the sound is 330 constant, 330, and Frequency, radiated sound from loudspeaker is 1000 here, 1000 hertz. Okay, and the speed of child approach to the source is 10 meter per second. Right, is value given by the question here. So now you can find the frequency heard by a child, or frequency refer to the observer here, is equal to 1030.3 hertz. Okay, let's see. So that's all. Thank you.